So up until this point, you've been looking at sets, and one of the things that we do with sets is try to use some Venn diagrams. So most of the notation that you see looks something like this, where I have A union B, which means your elements that are in A or in B, or you have your intersection, A intersection B, where they're in A and it's also in B. So for your Venn diagrams, and I'm not going to draw very good circles here, if this is set A and this is set B, actually, let's try that again, and I will use this guy. Ooh. There we go. And I have those two sets, and where this is A and this is B, and let's say I got 1, 2, 3, 4, 5, like this. If I want to talk about numbers that are in A or B, then that would be the set 1, 2, 3, 4, 5, because 1, 2, 3 are in A, and 3, 4, 5 are in B, so if you're in A or B, you get to be in the set. If I'm talking about A and in B, then you're only talking about this one little piece in the middle, the ones that are in both of them. So that's just going to be a 3. Now, often around the bigger Venn diagram is a universal set, and that is usually called U. So U will have the sets A and B in it, but sometimes it also has things floating around out here. So let's say 6 and 7 are out there. So even if I was still looking at this about things that are in A or in B, 6 and 7 would not be included because they're not in A or in B. The two Venn diagram ones tend to not be so bad. Right? This is the stuff that's just in A. This is the stuff that's just in B. And then you get this piece in the middle that's in both. The ones that seem to cause most of the problems are the ones that have 3. So I have this up here where I got set A is this oval, set B is this oval, and I have C. This piece right in the middle, this V, this set 5, this is the stuff that's in A, B, and C. Those are going to be the elements that are in all 3 sets. Set 2 is just stuff that's in A and B. That's the stuff that's in A and B, because even though some of them are in C, not all of them are in C. So if it's in this yellow section, we can say without a doubt that they're both in A and B. Now some of those things will pop up in C, but that's okay. The section over here, this section 4, is going to be the elements that are just A and C. And again, you're going to have some of those things that are in B, but for sure they're both in A and C. And then finally, you have this section, and those are going to be the elements that are in B and C. And just like with the other two, there are going to be a few that pop up in some other sets, but for sure they're in B and C. The stuff in 1 right here, all of this is the stuff in A. 3, that's the stuff that is in B. And this 7, that's the stuff in C. 8, not in any of those. So now what we want to do is we're going to take the information that they give us here, and we're going to create a Venn diagram, and we're going to kind of work backwards to fill in the rest of the information. So I got 93 cities. That's important. And I got 27 that had baseball, 22 had rugby, 18 had volleyball. 15 had baseball and rugby. 13 had baseball and volleyball. 11 had rugby and volleyball. 7 had all 3, and that is where you want to start. You want to start what's in all 3 and work your way out. So let's draw our circles, which we will not try to draw by hand because that will not work out well. Move this down, and then I need one more circle. Okay. So this section right here, this very middle section, that's the section that's going to cover all three things. I'm going to make this baseball, this volleyball, and this rugby. And the people, or the cities that had all three, that was 7. There were 7 cities that had all three. And now I'm going to work backwards. 11 had rugby and volleyball. So in this section right here, those are going to be the ones that have rugby and volleyball. But now I already have 7 accounted for. So that means 4 more cities just had volleyball and rugby. They only had volleyball and rugby, not this also, but I have to consider that this has already been counted. Okay, he's done. 13 had baseball and volleyball, so I'm talking about this section. I already have 7 accounted for, so that means 6 more. That section has to add up to what it says right here. Last double, baseball and rugby, there was 15 of those. I already have 7 accounted for, so that means 8 more. 8 had only baseball and rugby, but there were 7 cities that had baseball, rugby, and the volleyball. So now I can work for that last section. 18 had volleyball. Well, this whole circle, if I add this up, this has to add up to 18. Right now I got 6, plus 4 is 10, plus 7 is 17. That means there's one city out there that only has a volleyball team. That's pretty unusual. Rugby circle. The whole rugby circle has to add up to 22. Right now I got 12 plus 7 is 19. So that means there are 3 more cities out there that only have rugby. Baseball. Baseball has to add up to 27. Right now I got 13 plus 8 is 21. So there's 6 cities that have baseball. But we're not done yet, because everything that's accounted for in here probably doesn't add up to 93. Let's see what it adds up to. Let's see, I got 6 plus another 6 plus a 7 plus an 8 plus 1 plus 4. Shoot. All right, that should be a 4, so I'm going to make this a 2. 35. Let's add it one more time to make sure that we're right. 6 plus 6 plus 7 plus 8 plus 1 plus 5 plus 3. 36 this time. 6 plus 6. It's bad when you can't add with the calculator. Plus 1 plus 4 plus 3. 35. Okay, I thought I had something wrong last time. So this all adds up to 35. But I surveyed 93 cities. So that means 93, only 35 answered. That means 58 of them don't have baseball, volleyball, or rugby. That is the number that's going to go out in the universal set. As soon as I find the drawing feature. So 58 didn't have any at all. So the way this looked in my math lab was like this. They want to know how many only had a rugby team. Well, according to this, 3 only had a rugby team. How many had baseball and rugby but not volleyball? So let's look at our diagram. This had baseball and rugby, so this, and this. And we want to know who had baseball and rugby but not volleyball. So then that would have to be these guys, because over here would have volleyball, over there would have volleyball, and this would have volleyball. So it has to be 6 plus 8 is 14 plus 3 more is 17. Uh-oh, calculate number in city 2. Oh, did I add up the wrong section? Oh, baseball and rugby at the same time. So that means they only want this right here, baseball and rugby, but not volleyball. So they actually only want this. sometimes that happens. You read it one way and they meant to say something a little bit more specific. Now baseball or rugby didn't say anything about volleyball, so I guess volleyball is, we're going to have to guess that volleyball is okay. So everything but this little one out here can come out. All of this added up to 35, so we're going to have to say 34. And how many have baseball or rugby but not volleyball? So baseball or rugby but not volleyball, and that would be what, the number that we thought before. Baseball or rugby, or I guess both is going to have to be okay, but not volleyball, and that was 17. Yeah, that was 17. How many had exactly 2 teams? And this is the last question. The ones that had exactly 2 teams are going to be the ones in this little area throughout here, because this part has baseball and volleyball. This has volleyball and rugby. And this has baseball and rugby. Can't count this on the inside because they have 3. So 18. And that's how you work with 3 circle Venn diagrams.